You are still having trouble with the square thing here, but it's basically the same thing. You're trying to leave the n by itself. Right now there's nothing to simplify, so if I'm doing PEMDAS, right, on the left or the right, there's nothing to simplify, so there's nothing to do. Now I can start transferring things around, so now I need to undo. So undoing, that's when we start transferring things around from one side to the other. So I got to do all my adding and subtracting first. So in this case, these two different families are being subtracted. This is called a constant family, this is a n squared family, and this is a constant family. Because you name your terms, terms are things that are being separated by minuses and pluses. You name them by the letter and the power of the letter, the variable and the power of the variable. Okay? So in this case, this -7 means that you're subtracting 7. So since I'm undoing, then I need to add 7. And I'm working with my adding and subtracting first. Okay? That means that this guy here just comes down. And of course, when you're adding and subtracting, if they're opposite signs, you subtract. I owe 167. I have 7, so when I pay what I owe, I'm going to still owe 160. So negative 167 plus 7 is negative 160. Well, now I've done all my adding and subtracting. So now I need to move on to multiplying and dividing. If you notice, when the number is right next to the letter, that's multiplying. So if I need to undo that, then I need to divide. And I'm going to divide with the same sign, because when I divide those, if they are the same sign, then I end up with a positive 1. And that's what you want. You want this invisible 1 right here, so that you can leave the n by itself. Over here, you are dividing two negatives. So again, when you multiply and divide, right, that's when you can think of El Chinito. So negative negative is positive. And half of 160, or 160 divided by 2, should just give you 80. So negative negative is positive, 160 divided by 2 is 80. And then you have to remember, again, you're still undoing. So what gets rid of that square? Okay? So now we're over here with, we already finished multiplying and dividing, we're over here with exponents. Okay? The inverse of the exponent would be square root. The inverse of exponent of 2, or power of 2, would be square root. So then you have to square root both sides. You see that? That cancels that square and that square root, leaving you only the n. So using that concept there, we're going to have to take this square root of 80 and simplify it. We're going to do that over here on the side somewhere. Let's take that square root of 80, let's see down here, and think of two numbers that multiply to 80. When it ends in a 0, I love to use 10. So I'm going to use 10 times 8. So we know 8 to be 4 times 2. And if you remember your prime numbers, very important, we're going to break them down all the way to our prime numbers. That's 2, 3, 5, 7, 11, 13, on and on and on. Only numbers that can be divided by itself and 1. You need two different numbers. That's why I cannot use the 1, because the 1 would only be 1. So then these numbers have itself and by 1. You can divide them evenly. So this is the prime number. I'm going to close my tree right there. I continue my tree with a 4, which gives me 2 times 2, and they're both prime. So these branches are closed already, right? And this one can still branch off. So that's 5 times 2. 5 happens to be prime, so that piece of the branch closes. And 2 is prime, so that piece of the branch closes. So now right here you can see how we're trying to find pairs, and the reason for that is because when you have two factors that are being multiplied, you can write them as a square. You see that? So this right here happens to be 2 squared. These 2 right here happen to be 2 squared. We also have the 5 that is also one of the factors, right? But it's by itself. So that one stays in the little square root by itself. Why? Because 80 is the same thing as saying 2 times 2 times 2 times 2 times 5. If you already put all those numbers in the calculator and you multiply them, you get 80. Okay, so I just rewrote 80 with multiplication of factors of 80. And here you can cancel those things. You see how this concept of the square and the square root cancel each other out? So it's like if all of this disappeared and all you had was a 2. Over here, the same thing. It's like if the whole thing disappears and you just have the 2. Now you can't do anything with the 5, so that one stays with the square root. And anything that goes outside multiplies, anything that stays inside multiplies. So in this case, I have 2 times 2 giving me 4 on the outside, and then the square root of 5 on the inside. So my final answer is going to be n equals plus or minus 4 square root of 5. Why consider the plus or minus? Because you got to remember that when you square something, it can be positive or it can be negative, and you'll still get a positive number. Okay?